Hi and welcome to the lesson on composite functions. So composite functions are when you find a function of a function. The one above here, how would you say that? What is f of g of x? That's how you would say that. F of g of x. So that instruction would be find f of g of x. So basically meaning sub g of x into f of x. So this topic follows on well from the function notation lesson. So instead of substituting in a value of x, we instead replace x with another function and then expand and simplify where appropriate. So I'll just get straight into some examples for you. So for f of x equals x plus 2 and g of x equals 3x minus 1. Find f of g of x. So notice what it means is g of x gets subbed into f of x. So g of x gets substituted into f of x. So f of x is x plus 2. So f of g of x would be, so let's put, instead of x, we're going to put 3x minus 1, and then we've still got plus 2 there. Plus 2. So f of x is x plus 2. What we've done is we've replaced x with 3x minus 1. And then we just simplify anything we can. So therefore f of g of x, which is what we've got above as well, is 3x minus 1 plus 2 is plus 1. There we go. Done. So notice so the order is important. That was f of g of x. This next one, we want g of f of x. So f of x gets subbed into g of x. So f of x gets subbed, instead of writing substituted, into g of x. So the other way around this time. So g of x is 3x minus 1. Whenever we see an x in g of x, we're going to replace it with f of x. So it's going to be 3 brackets. So x plus 2 gets subbed in, because instead of x we have x plus 2, because we're subbing in f of x wherever we see x in g of x. And don't forget we've still got minus 1 at the end. So in red is basically what was the function before, 3x minus 1. But what I've done is whenever I've seen an x in g of x, I replace it with f of x instead. And then we just do any simplifying, expanding, collecting like terms. So it becomes 3x plus 6 minus 1. So g of f of x equals 3x plus 5, because all we've done there is collected like terms. 3x plus 5. Okay, let's keep going to get the hang of it. G of x. So basically we just sub g of x into g of x. So g of x is 3x minus 1. So instead we've got 3, and instead of x we sub itself back into it. 3x minus 1, close the brackets, minus 1. So see, the overall function is 3 brackets x minus 1, and where there was an x, we've replaced it with g of x itself, 3 of x minus 1. So that's actually possible to do. So that becomes, when you expand it, 9x minus 3 minus 1. So g of g of x equals 9x minus 4. And last one on here, f of x. So we're subbing f of x into f of x. F of x is x plus 2. So we sub in x plus 2 where we have the x, and don't forget there's still the plus 2 at the end. So that means that f of x equals x plus 4. And that's those examples. Here's another one. Subbing functions into functions, a new set of functions. F of x equals x squared, g of x equals 5x. So find f of g of x. So we need to sub g of x into f of x. F of x is x squared. So open up the brackets, put in g of x, which is 5x, close it up and square it. It's easy enough to do. So therefore f of g of x equals 5x times 5x, which is 25x squared. Nice. And then g of f of x means we're going to sub f of x into g of x. G of x is 5x, so 5, open up the bracket, and then we've got to sub in x squared. X squared, there's nothing outside of the 5x. So 5x, and then we've replaced the x with what f of x is, which is x squared. And of course 5 times x squared is just 5x squared. So g of f of x equals 5x squared. Yes, if you prefer. And another page of examples. G of x. Now what was g of x? G of x was 5x. So we're going to go 5, oops, yeah, we can do it in yellow. 5, and then sub in 5x instead of x. Instead of 5x, we write 5 by 5x. So that's g of x. What is 5 times 5x? It's just 25x. It's done. And then f of x. So as you can see below, g of x was 5x. X squared, f of x is x squared. So it's going to be x squared, but it's like x squared. I'll do it in a different colour. So open up the brackets, sub in x squared into x squared. So that means that that itself has been squared, which would give you f of x equals x squared squared, which I'm guessing you remember exponent laws, multiply the exponents, or think of it as x squared times x squared, x to the power of 4. Brilliant. Now some more examples, got some new functions here to work out. F of x is square root of x, g of x is x plus 2. So find f of g of x means sub g of x into f of x. So f of x is the big square root, and into where we've got x in there, we're going to replace that with x plus 2. That's g of x has been subbed in. So that looks like that one's been done, because that looks simplified already, doesn't it? So that's f of g of x equals square root of x plus 2. Simplified already. And then g of f of x means sub f of x into g. So g of x is x plus 2, f of x is square root of x. So x plus 2 is the overall function we're trying to write. We've got to replace the x with the other function, which is f of x. So square root of x, don't forget the plus 2. That looks pretty simplified already too, doesn't it? So g of f of x equals square root of x plus 2. Just pointing out, some books kind of write these in a different way. Sometimes they write things like g of f of x, things like that. So sometimes they use different symbols, like g with a symbol, f of x. So I've tried to write it the way our textbook, I think, tends to write it. In IB you might sort of see a few examples where they write it more like this, g of f of x, that kind of thing. But for now, we can think of it more like as given in that kind of way. So let's circle our answer. And are there any more examples? Yes, there is. G of x. So we're subbing g of x into itself. So you can see above, g of x is x plus 2. So we got the right one. G of x, yep, x plus 2. It's subbed into x plus 2. So don't forget there's a plus 2 at the end. So therefore g of x is x plus 4. We do correct like terms. And f of x. F of x is square root of x. So it's the square root of the square root of x, which you might realise automatically is the fourth root of x. If you're having trouble seeing that, think of x, remember square root of x happens to be the same as x to the half. And then to square root, that means to raise it to the power of a half, which happens to be the same as x to the quarter, which is the same as the fourth root of x. So don't forget, we've got f of x. And thank you very much. That is the end of the lesson.